Hi, I'm Jim, KC9VKV, and we run the Qso-Vlog network on Friday afternoon from 3:30 till 5. We record live and then post it up on YouTube along with a written description. Well, a lot of folks check out our YouTube video using their cell phones, which is okay, but you may be missing the written description part. So here's a translated version of my group AIRCHECK 11.8.19. Well, I've had a few weeks now to test out and evaluate my two 10-foot magnetic loop antennas. But FYI, my first test sequences were with a smaller 1-meter mag loop at 100 watts on 7188 megahertz. It was AB'd against my main 40-meter dipole. This is where I learned size makes a difference. I could barely hear that small mag loop at 700 miles away. It was then I realized if I were going to give mag loops a chance, I would have to start thinking bigger. Hence my first 10-foot magnetic loop antenna. And my next tests were AB'd again against my normal half-wave dipole. Now, to be honest, this dipole is a perfectly tuned resonant dipole. It's cut specifically for 7188. The normal SWR reading for this antenna on 7188 is 0.02 SWR. And it is oriented specifically for coverage of the eastern portion of North America. Our mantra when we first started building our station was 20 over from Montreal to Miami and from New York to New Mexico. The New Mexico part is still in question. I say all this just to point out how much of a challenge my first 10-foot magnetic loop antenna was facing in a shootout against my 40-meter dipole. I primarily used the MILFORD PA Internet SDR receiver as a test target. The distance to target was 700 miles. I picked the MILFORD SDR because it seemed to be always hot, and I needed to be able to rock and roll on my schedule, not to have to wait around for conditions. So the first part of my test involved using the 10-foot mag loop in a transmit configuration. These were AV tests less than 2 seconds apart to catch the same conditions and repeated 4 times as a sequence. All tests were on 7188 megahertz. The test utilizes a comparison AB at 100 watts and 1 kW using my special 50 kW red gold tomato can tuner capacitor on the mag loop. A summary of those tests revealed that, in general, the dipole was hotter by at least 1 S-unit, and sometimes 2 to 3 S-units. These tests were conducted using an unmodulated AM burst of 3 to 5 seconds, repeated 4 times as a sequence. We referenced the Internet SDR meter. And shortly, we realized that, in general, our dipole had the edge as being the best transmit antenna. So then we started to A-B compare the mag loop and our perfect dipole in the receive mode. And again, all A-B receive tests were done on 7188. So this involved staking out 7188 for a few days. One of our first receive A-B tests involved a Canadian network meeting on 7188, and this was just outstanding. The mag loop had 3 dB less ambient noise and a 4 dB hotter audio signal than my dipole antenna. To put it another way, the mag loop was 7 dB better than my dipole in receive. However, other test comparisons were not that dramatic and fell into a 50-50 ratio. So looking for the absolute best antenna, I decided to stack the mag loop. The final solution was a second twin 10-foot mag loop mounted 90 degrees to the first. It comes in on a 3-position rotary switch. Mag loop 1, mag loop 2, and a third co-phase option. And I have to admit, the co-phase option has often turned out to be 3 to 4 dB hotter than either my mag loop by itself. So we'll have more later.